You're listening to the Bare Metal Cyber Prepcast, created to help you succeed in your Cloud Plus certification journey. Learn more at baremetalcyber.com, where additional prepcasts, books, and training materials await. Let's get started. Troubleshooting begins with identifying the problem. Before systems can be restored or mitigations applied, the nature of the issue must be fully understood. This step is more than noticing that something is broken. It involves defining exactly what is malfunctioning, which users or services are affected, and what has recently changed in the environment. Skipping this step or approaching it superficially can lead to wasted effort, misdirected fixes, and prolonged downtime. In cloud environments, where complexity and abstraction increase diagnostic difficulty, clear problem identification becomes even more vital. The Cloud Plus exam often presents scenarios where symptoms are vague or ambiguous. Candidates must analyze minimal information, perhaps a generic alert or a user complaint, and clarify it through investigation. The purpose of this first troubleshooting step is to gather enough context and data to transform vague symptoms into a defined, reproducible issue that can be further analyzed. Without this foundation, even technically sound solutions may fail to resolve the true root cause. The first source of useful information is error messages and system alerts. Logs, monitoring dashboards, and alerting tools often provide the earliest signs of trouble. These may include response codes, command line outputs, service errors, or security event notifications. Capturing this data early is critical, as it may be overwritten or lost in transient systems. Screenshots or copies of relevant outputs help ensure nothing is missed when reviewing the event later or escalating to another team. User reports are another valuable source of initial problem data. End users and frontline support staff can describe the symptoms they observed, when the issue occurred, and what they were doing at the time. However, their reports often use vague terms like "it's slow" or "it's broken." Clarifying these statements through targeted questions, such as identifying what page was being used or whether a specific feature failed, helps narrow the problem scope. Understanding the user's context can also highlight whether the issue lies with the application, the user's device, or something in between. System and service logs provide deeper insight into what occurred during and before the incident. These logs may contain warnings, rejected requests, failed dependency calls, or timeout errors. In complex cloud environments, centralized log platforms or parsing tools are often required to sift through these logs efficiently. Log filters can isolate entries by timestamp, service, or error code, while built-in search tools in platforms like AWS CloudWatch or Azure Monitor allow rapid identification of patterns. Monitoring dashboards provide real-time and historical data that can confirm when performance dropped, traffic shifted, or availability was lost. Dashboards might show CPU or memory spikes, IOPS degradation, unusual latency, or failed service checks. Combining this data with the time of user reports can help triangulate when the problem started and how it progressed. Dashboards also help verify whether the issue is ongoing or has already resolved itself, aiding urgency determination. Defining the scope of the issue is another crucial early step. A problem affecting a single user has different implications than one impacting an entire region or multi-tenant platform. Scoping the issue helps assess severity, assign it to the correct team, and decide how much attention it requires. For example, a failed deployment in a test environment might be lower priority than a regional authentication outage. Scoping supports prioritization and reduces the risk of overreacting or underreacting to a problem. Identifying recent changes is one of the most effective ways to spot root causes. Most outages are caused by something that changed, whether a configuration, a code deployment, a security policy, or a platform upgrade. Reviewing change logs, patch histories, and recent deployments can immediately surface a likely culprit. Configuration management databases and change approval systems provide a historical record that helps correlate changes with symptoms. It's important to separate symptoms from root causes. A system might be slow, but slowness is a symptom. The actual cause could be a misconfigured load balancer, a storage bottleneck, or a runaway process consuming CPU. Identifying the difference between what is observed and what is causing the observation is the essence of good troubleshooting. Jumping to conclusions based on symptoms without further investigation leads to delays and misdiagnosis. Tags and metadata help narrow the search. In cloud environments, resources are tagged with names, environments, teams, and regions. Using these tags, teams can filter dashboards and logs to isolate relevant systems. For example, if a failure is isolated to the US East region, tags can be used to show only resources in that zone. Inaccurate or missing tags hinder this process, making issue scoping more difficult and increasing the time to resolution. Finally, before moving to deeper investigation, teams must confirm that the problem is real and reproducible. Sometimes reported issues cannot be duplicated or are caused by external conditions like intermittent internet issues or third-party API failures. Attempting to reproduce the issue in a controlled test environment or by following user steps ensures that resources aren't wasted solving a phantom problem. Reproducibility also helps validate theories in the next troubleshooting stage. For more cyber-related content and books, please check out cyberauthor.me. Also, there are other prepcasts on cybersecurity and more at baremetalcyber.com. Once technical data is collected, the next step is to classify the incident by type. Categorization helps direct the issue to the appropriate team or process. Most problems fall into categories such as performance degradation, connectivity failure, access denial, security events, or deployment misconfigurations. Each category implies a different troubleshooting path. For example, a connectivity issue will guide the investigation toward network interfaces, routing tables, or firewall rules, while a deployment failure points to pipelines, version mismatches, or container registries. Assigning severity and business impact is a parallel task. A problem affecting a handful of non-production systems may be low impact, while a similar issue in a production environment affecting revenue-generating services could be critical. Impact assessment considers not only technical severity, but also business functions disrupted, user visibility, and contractual obligations. The assigned severity informs which teams are alerted, how quickly response is needed, and whether escalation protocols are activated. Time of incident is one of the most important details to document. Knowing exactly when the issue started allows teams to align logs, metrics, change history, and monitoring events. Time-based filtering is essential for isolating relevant data from the noise. Additionally, knowing whether the issue is ongoing, intermittent, or occurred only once affects both triage strategy and resource assignment. Repeated failures may indicate systemic faults, while isolated events may stem from transient dependencies. Another key part of identifying the problem is pinpointing which services, systems, or application programming interfaces are affected. In cloud environments, services are often interdependent. One failing component might cause downstream services to report errors even if they are functioning properly. Service dependency diagrams, trace logs, and API call maps help visualize which parts of the architecture are directly impacted. Cloud Plus candidates must be comfortable using these resources to narrow the focus of investigation. Identifying what is unaffected is just as valuable. Comparing working systems to failing ones provides contrast that supports root cause isolation. For example, if two virtual machines in the same cluster behave differently, the difference might reveal configuration drift. If users in one region are impacted while others are not, the scope becomes clearer. Side-by-side comparison creates patterns that help eliminate red herrings and reduce diagnostic time. With enough data gathered, a clear and specific problem statement can be created. This statement should describe what is broken, where the issue occurs, when it was first detected, and under what conditions it manifests. Vague summaries, like database failure, are not sufficient. A complete statement, such as API service in US East 1 is returning 503 errors under load since 11:47 a.m. after deployment of version 2.8.3, provides an actionable foundation for the remaining troubleshooting steps. Sharing findings with stakeholders is essential. Even at this early stage, communicating what has been observed and what remains unknown helps align the broader team. Updates may go to system owners, help desk coordinators, on-call engineers, or security analysts, depending on the issue. Sharing scoped and verified information prevents duplicate work and ensures that response planning begins with a shared understanding of the problem landscape. Documentation of early findings should be formalized within change tracking systems, incident tickets, or internal reports. This includes logs collected, user statements, system snapshots, and dashboard captures. These records support ongoing troubleshooting, change reviews, and eventual incident retrospectives. Without documentation, critical observations may be lost as the issue evolves or escalates to other teams. It's important to resist the temptation to fix the problem before it is fully defined. Applying quick fixes based on partial information can introduce new issues or obscure the original failure. Premature changes may make the system appear stable temporarily but prevent proper diagnosis. Until the problem is defined clearly and the scope is confirmed, teams should focus exclusively on data gathering, reproduction, and scope validation. Problem identification isn't just a one-time step. In complex incidents, the understanding of the issue may evolve as new information is discovered. Teams must be prepared to revise their problem statement, adjust severity, and reclassify the incident if new symptoms appear. This flexibility ensures that troubleshooting remains aligned with the facts, and that resolution efforts are based on the most current understanding of the problem space. Thanks for tuning in to the Bare Metal Cyber Prepcast, your trusted source for cybersecurity news and insights. Remember to subscribe at baremetalcyber.com so you never miss an update. And visit cyberauthor.me for best-selling cybersecurity books that equip you with expert knowledge. Until next time, stay secure and stay vigilant.